This is not a jet engine, but a turbomolecular pump, which is too expensive to buy. Fortunately, my friend bought some beer, so I asked him to take a look. After much persuasion, he bought 2 of them. This trip was not in vain. It's basically cool enough. Look, at the middle part of this power, there are some colors on it that should be metal oxide. The thickness of the oxide determines its color. This thing is similar to the oil film on the water surface. It does not affect the use. It is pretty beautiful when it rotates. It's still pretty dirty here. Probably the oil from the primary pump and the diesel fuel from the construction process. So it should be removed and cleaned. Alas, there's a warranty label here, which means that if you take it apart, the warranty will be void. Still guessing. Let's first take off the bottom cover, and then use 2 screws to push out the magnetic shaft layer. Let's get to it. Okay, it's out. Continue. To remove its shell. Take down the jingy wheel, that is, it is customized, which is half. Look here. There are 2 positioning pins. Put the 2 pieces together. Dylan is a whole circle, and then take down the fixing ring. The compression ratio of a single impeller is very small, so the dynamic impeller and the static impeller are arranged alternately to form multiple compression sections. Only then can we achieve a clean ultra-high vacuum. After guessing, I looked at it carefully. It's custom made, so it's a little dirty. It's all covered in oil. The rotor is relatively clean, but this thing weighs over 12 pounds and is about 27 centimeters long, so it's more stable when you set it down. Now, let's give it a bath. A deep clean. Make sure to wear gloves and a mask. For second-hand vacuum equipment like this, if you don't know what it was used for before, it's best not to touch it directly with your hands, and definitely avoid inhaling any dust produced by the equipment. Just take your time to clean it up properly, and it should be fine. I spent the whole day cleaning the static rotor base, dynamic rotor, outer shell, and all these retaining rings. It's all assembled now. Let's give it a try. As you can see, the rotor is spinning normally. We can power it on again to test it out. As you can see, there is no problem either. This thing can reach a speed of 30,000 revolutions per minute, and a pumping speed of 1,400 liters per second. When opened in normal atmosphere like this, due to air resistance, in order to avoid damaging the blades, it will not run at full speed. It needs to be used in a certain level of vacuum to unleash its full power. And now, I just need a vacuum gauge. I'm at the physics department's waste storage, and there are some good finds here. I basically come here to rummage through once a week. These things aren't very useful, but take a look over here. Ha ha ha. This is exactly what I need, but this thing is too big. I can't take it without a crane. There's a smaller one here, and I can already take that back to the studio. This thing is pretty dusty, so I'll give it a quick clean first. I really don't understand how such a good item ends up here. How did it get in? It just had to. Of course, this thing has quite a few holes. There are 2 door panels that can be used to seal the large holes at the front and back. The round hole on the right can be used to install a turbomolecular pump. I measured it, and the hole diameter is too large, so the original flange needs to be used. Secure it on the lathe. Process the central mounting hole according to the size of the turbomolecular pump. Then drill 12 screw holes for fixing. Use this stainless steel threaded insert. Twist it onto the special tool. See? It can easily embed into the aluminum like this. Very convenient. After finishing all 12, carefully polish the contact surface. To ensure good sealing, I bought a sealing ring, tried it, but it didn't fit well. So I cut off the excess part and used strong glue to join it together. It seems okay. It will do. Next, assembling it was no problem. It fits perfectly. Install the processed flange in place. Use a torque wrench to tighten all 16 fixing screws. Carefully lift the molecular pump up. This thing is really heavy. Dozens of pounds, almost couldn't lift it alone. Got it done. Let's look at the details. Very well done. The hole on the left is used as an observation window made of glass, with a diameter of 300 millimeters, meaning it needs to withstand over 700 kilograms of force. The glass can't be too thin. Otherwise, if fragments hit the molecular pump, it would be a big loss. So, how thick should it be? Anyway, the thicker the better. I bought a borosilicate glass disc with a diameter of 300 millimeters and a thickness of 20 millimeters. Look how thick it is. 8 fasteners are used to secure the glass window, with a layer of rubber pad on the inside to prevent the glass from being damaged by pressure. A layer of rubber is also added to the sealing surface to avoid direct contact between the glass and the metal. There are still remaining screw holes among the 8 fasteners, directly 3D printed, to secure it in place, treating it as a decorative piece. Then print a longer one, embed an LED bulb into it for illuminating the vacuum chamber, and install it at the bottom. Alright. Open a small vacuum pump and place it at the bottom of the frame as a 4-pump, connecting it to the turbomolecular pump. Use it to pre-process and achieve a vacuum, allowing the turbomolecular pump to start working. This device also requires high-quality vacuum pump oil. It's a bit expensive, so I got a bottle from a friend without spending a penny, which is great. Use a syringe to inject 2 tubes of it. Install the ultra-high vacuum gauge and add an old electric vacuum gauge to monitor the pressure within the high vacuum range. First, turn on the forepump to evacuate the chamber. After a long time, the turbomolecular pump can be turned on. After an hour of pumping, the rotational speed of the molecular pump has reached 31,500 revolutions per minute, and the system has entered the high vacuum range. What do you think such a vacuum chamber should be used for?